Hi there, my name is Vince Harabidis, and in this video we will continue our series of videos on absolute value equations, and this time we will see two new extra types of exercises. So let's begin by clearly writing the video's title, which is again on the absolute value equations. And let's remember together that so far we have seen and we should have known these three cases. First of all, how to solve the case when an absolute value of x is equal to something positive. Let's call that theta, in where we need to split it into two different cases. Secondly, how to solve the equation absolute value of x equals 0, where in this case, we only get that x equals 0. And thirdly, how to solve the case in which the absolute value of x is equal to something negative, which in this case leads to no solution, since after all, the absolute value stands for distance. Remember as well, or you should know as well, that when we refer to absolute value, it's not just about the x, but it's about the expression inside the absolute value. Now, moving on, we will see a fourth case, that of the absolute value of x being equal to the absolute value of y. If we want to give a geometrical interpretation of this, we are looking for two numbers. We need to find two numbers, x and y, the distances of which from 0 are the same. So if I create a number line and I put 0 somewhere in the middle, we need to get two numbers that have equal distance from 0. Apparently, one case should be the case in which both numbers are the same, x and y. Indeed, in this case, the absolute value of x is this distance, and the absolute value of y is this distance. And since we refer to the same distance, it makes sense. These two absolute values are equal. Is this the only case, however? Let's see. We could have had as well x here and y on the exact opposite side. Think of numbers 3 and -3, 5 and -5, 10 and -10. All these pairs of numbers are equidistant, meaning they have the same distance from 0. The distance between 3 and 0 is 3 units. The distance between -3 and 0 is 3 units. The distance between 5 and 0 is 5 units. The distance as well between -5 and 0 is also 5 units, and so on. So even in this case, that would stand for the absolute value of x, and that would stand for the absolute value of y. And if we want to sum up all this, we would have said that we have one first case where x and y are equal, and the second case in where x and y are opposites. In math words, in math symbols, all this inquiry that we just did can be expressed as follows. Absolute value of x equals to absolute value of y if and only if. Again, we get two different cases. these x and y expressions are equal, or these x and y expressions are opposites. And remember that it's not just about a single x value and a single y value, it's about expressions. Similarly to those, if we have an expression A being equal to an expression B, this would mean that A is equal to B or A is equal to negative B. Let's work on some examples. Absolute value of 2x plus 1 is equal to absolute value of x minus 3. Sorry, let me do that more proper, like that. So remember that, and let's write it somewhere here so that we have that clear. X equals y or x equals negative y. So in this case, we should work with these expressions inside, with the expression 2x minus 1 and the expression x minus 3. And based on what we know from theory, we would get 2x plus 1 is x minus 3, or 2x plus 1 equals minus x minus 3. Now, I simply need to solve these two new equations separately. So 2x minus x is minus 3 minus 1, which means x equals negative 4, or 2x plus 1 equals minus x plus 3, which means that 2x plus x equals 3 minus 1. So 3x is 2, which further means that x equals to 2/3. And these two are the solutions. Let's do another example as well. 5x equals to x plus 9. Once again, since we have an equality between two absolute values, one absolute value on one side and another absolute value on the other, all we have to do is simply start working, applying the theory we just learned, and work with the expressions inside these absolute values. So we would get that either 5x equals to x plus 9, or 5x equals to minus x plus 9. And now each one of these new equations separately. So 4x is 9, which is x equals 9 over 4, or 5x is minus x minus 9, 5x plus x equals 9, 6x equals 9, so x equals 9 over 6, and both are accepted. Be careful, however, as always, in order to apply this type of solution, this type of process, we need to be clear. We need to have the exact same setup. One absolute value with a positive sign on the left side and another absolute value on the right side. Nothing else. Let's go to the fifth case. In this case, which some of you find the hardest one, although it's not the hardest one, we have absolute value of something being equal to a restriction. Being equal to an expression, but I was thinking forward. Remember that in this case, there should be a restriction. Always, in many cases in math, one of the first things that we should do before approaching the solution is setting up the restrictions. It's as if we say, okay, I'm going to solve this, but to make it clear, this equation that I was given only makes sense for these values. This is called the restriction. Why do I need that restriction? I need to use that in the end. Once I have my final solutions, I will have to check whether these satisfy that solution. Because remember, restriction means finding the values for which this thing that we have in front of us makes sense. Now, with regards to this expression, let's go on some inquiry. Assume that I have this statement, A equals B. Assume now that I'm telling you that A is 2. By fact, A should be 2. What should the value of B be? Most of you answer in class that B should be 2 as well. And you are right, because I just gave you the original statement that A and B are equal to each other. So if one is 2, the other should be 2 as well. If A is 9, B should be 9 as well. If A is minus 3, regardless of what, B should be negative 3 as well. If A is equal to this hard, then okay, B should also be equal to that hard. If A is a positive expression, then B should be a positive expression, and so on and so forth. So if we get this concept, let's see how we can apply that on this fifth case. I'll call this left-hand side, and I'll call this right-hand side. It's as if I had the A and the B. With regards to the left-hand side, what do I see? We have an absolute value. What do I know about an absolute value? That it always stands for distance. I know that absolute value is distance. What do I know? What have we said with regards to distance? That distance is always greater or at least 0. So, to recap, on the left-hand side, we have an expression which is greater or equal than 0. But if the left-hand side and the right-hand side are equal, by fact, we were presented with that, and the left-hand side is greater or equal than 0, won't this make the right-hand side as well greater or equal than 0? And this here would be our restriction. We will find that, and then we will, let me write that. Once we have it, I will proceed in solving in the exact same way I knew so far, meaning that I will take the expression inside the bracket, I will make that equal to the positive expression or to the negative expression. But let's see a worked example, because through it, it will make more sense. Absolute value of x minus 2 is equal to 3x minus 6. Or not, let's make that 3x minus 3. So again, remember, in these cases, we have restrictions. We need to set it up. The left-hand side is always greater or equal than 0, since it represents a distance. The right-hand side as well should be greater or equal than 0, which means that 3x minus 3 should be greater or equal than 0, which means that now we need to solve for x. 3x greater or equal than 3, x should be greater or equal than 1, which means that only for these values of x, the given equation makes sense. We'll keep that for now, and we will return in the end. Now that I have set up my restriction, I will go on as I should before. So absolute value of x minus 2 is 3x minus 3, means that absolute value of x minus 2 is either equal to 3x minus 3 or x minus 2 is either equal to the opposite of that. I need to solve these two separately. So x minus 3x is minus 3 plus 2, which means that negative 2x is equal to negative 1, which means that x is equal to minus 1 over negative 2, x is equal to 1 half, or x minus 2 is minus 3x plus 3, x plus 3x is 3 plus 2, 4x is 5, x equals 5 over 4. Should I accept them both? Hold on. Now we need to be reminded of the restriction. In the beginning, we said that only the values of x which are greater or equal than 1 will make sense in this equation. So x equals 1 half doesn't make sense. If it doesn't make sense, would mean that we should reject it. X equals 5 over 4 is greater than 1, so we should accept it. This is the only solution. Here, you should keep in mind that not always we will accept one of them. We might as well accept them both, we might as well reject them both, or keep one of them. That's all for now. I hope this video helps to clarify these two new types of equations by using absolute values. If you still have any issues, if you still have any questions, please feel free to leave your comment below the video. As always, thank you for your time.